In this video, we'll learn a property of similar triangles. Here we can see two similar triangles, A, B, C is similar to P, Q, R. So we write it out, triangle A, B, C similar to triangle P, Q, R. If the triangles are similar, their corresponding sides are proportional, which means AB over PQ will be equal to BC over QR and will be equal to AC over PR. This is the property of similar triangles. If triangles are similar, their sides are proportional. But here we are going to learn yet another property. And the property is about the area of the triangle. So area of ABC over area of PQR will be equal to AB over PQ the whole square. Will be also equal to BC over QR the whole square equal to AC over PR the whole square. So here we see that the ratio of the areas is equal to the ratio of the squares of their proportional sides. This is the property we are going to use in this exercise. Now for the first sum, here it is given triangle ABC is similar to DF. So we have ABC is similar to triangle DEF. So let's write that. So triangle ABC similar to triangle DEF. Now the areas are 64 and 121. If EF is 15.4, find BC. So when we go to the property, we know that area of ABC over area of DEF equal to AB over DE the whole square, then equal to here BC over EF the whole square, and also now equal to AC over DF the whole square. In this sum, the areas of ABC is given as 64 and DF is given as 121. So let's write that. So 64 over 121 equal to. Now two more values are given. One value is given of EF. EF is given as here 15.4. So this is 15.4. So none of these values are given. So we cancel this out. We don't need, neither these values are given. So I just need BC over EF. Now BC I do not know. This BC is X. It's not given. I need to find out. So BC over EF is given as 15.4. And this is the whole square. So we take the square root on the other side and we get under root of 64 over 121 equal to BC. We take the BC as X now, since we have taken it as X here, over 15.4. Now square root of 64 is 8, 121 is 11, equal to X over 15.4. So 8 over 11 into 15.4 is equal to X. This answer comes as 11.2 centimeter, and we know BC is X is BC. So BC is 11.2. So we cancel this. Now this answer is 11.2 centimeter. The diagonals of trapezium ABCD, where AB parallel to DC, intersect at point O. So here is our trapezium A, B, C, and D. And the diagonals intersect at O. So let's draw the diagonal. This is one diagonal and this is the other diagonal. And they intersect at O. It is given to us that AB is twice CD. Find the ratio of the areas of the triangles. So first thing we need to show that the triangles are similar. Now we know here this angle will be equal to this angle because we have the Z alternate angles. So that's our first step. So we write DC parallel to AB, and we'll write this as angle 1 and we'll put this as angle 2. So angle 1 equal to angle 2, alternate angles. Now again this angle will be equal to this angle because again alternate angles. See this Z, parallel, transversal, parallel. So these two angles also will be equal. So we mark that angle 3 and angle 4. So angle 3 equal to angle 4, also alternate angles. The two angles are equal, hence a third angle will also be equal, and this is the third angle. So we'll mark it as, we'll write it as angle DOC equal to angle AOB, and vertically opposite angles. Now if three angles of one triangle is equal to three angles of the other, the triangles are similar. So we have triangle DOC is similar to triangle BOA. The triangles are similar. If the triangles are similar, we can write about the areas. So we know we can write area of DOC over area of BOA equal to, here we can write DC over AB the whole square. This is the property. So area DOC over area BOA equal to, we write DC, but however AB is given as twice CD. AB is given to us as twice CD. So wherever there is AB, here there is AB, I am going to put twice CD, the whole square. This cancels out. So now we have area DOC over area BOA equal to 1 by 2 the whole square, which means 1 by 4. Here, why are the triangles similar? By AAA test. To go back to the sum, here we first showed these two triangles as similar. These two angles were equal by alternate, and these two also were equal by alternate. And then you had this angle equal to this angle. So by AA test, the triangles were similar. And then we use the property that areas, here areas, ratio of areas equal to the square of the sides. In figure 6.44, ABC and DBC are two triangles on the same base BC. If AD and BC intersect at O, show that ABC over DBC equal to AO over DO. In this sum, we first have to draw two perpendiculars. So here are two perpendiculars drawn. I've drawn AP perpendicular to BC, and then we have drawn DQ perpendicular to BC. In the next step, I'm going to show these two triangles are similar. That is this triangle, which is triangle AOP, and this triangle, that is DQO. We need to show these two triangles are similar. So we're going to consider triangle APO and triangle DQO and show that they're similar. Now we know one angle is 90, as we have checked here. This is 90 and this is also 90. So we've got one angle equal. So we'll write angle APO equal to angle DQO. Let me mark that again. This is angle APO equal to angle DQO because each of them is 90. So this is 90. One angle done. Now there is a vertically opposite angles here. This angle, which is, and this angle are equal. How will you name this angle? This angle is AOP equal to angle DOC. We write that angle AOP equal to angle DOQ, vertically opposite angles. If two angles are equal of a triangle, automatically the third angle also becomes equal. That is, angle PAO will be equal to angle QDO. So we write that angle PAO equal to angle ODQ by angle sum property. So three angles of one equal to three angles of the other. So the triangles are similar. That means triangle APO is similar to triangle DQO. If the triangles are similar, the sides are proportional, which means AP over DQ. So we have AP over DQ will be equal to PO over QO. PO over QO will be equal to AO over DO. AO over DO. We will mark this as equation 1, which we are going to use later. So this was what we proved in the last slide. Now next we are going to take up triangle ABC, the area of ABC over area of DBC. Look up at the figure and see what is the area of ABC. So for ABC, this is ABC. This is area, this is ABC. Now it's half base into height. So that is half. You see the base here is BC, this is the base, and this is the height. So half base into height. So the base was BC and the height was AP over. Now we go to the other triangle DBC. Now triangle DBC is here, this is DBC. Here also area is half base into height. So the base here is same base. This is BC is the base of the triangle, and this is the height of the triangle. We're talking about the triangle DBC. So that would be half, the base was BC, and the height was DQ. We cancel half. So we have area ABC over area DBC. BC also can be cancelled, is AP over DQ. But look at 1. What does 1 say? What is AP over DQ? AP over DQ is PO over OQ. So we put that in our figure. So we have area ABC over area DBC equal to AP over DQ. But AP over DQ is equal to AO over DO. Here, AP over DQ equal to AO over DO. So this is by 1. Therefore, area ABC over DBC equal to AO over DO. Let me go over this part. See, when we took triangle ABC, this was the base here, BC was the base, and here was the height. So we did that half base into height here, BC into AP. And then the second we took triangle DBC, and the base was here BC, and this was the height. That's exactly what we have written here, half BC into DQ. If the areas of two similar triangles are equal, prove that they are congruent. So here we have two similar triangles. So given to us two similar triangles. So say triangle ABC similar to triangle PQR, and their areas are equal, which means area ABC equal to area PQR. We need to prove that the triangles are congruent. So to prove that triangle ABC is congruent to triangle PQR. So let us start with what is given to us. It was given to us that triangle ABC is similar to triangle PQR. If the triangles are similar, their sides are proportional. So which means AB. So we go to the property of area. That means area ABC over area PQR equal to AB here over PQ the whole square equal to BC over QR the whole square, BC QR the whole square equal to AC PR the whole square. This is the property of similar triangles. But these triangles have equal areas. See here they've given the areas are equal. So for area ABC I write, here I can write also area ABC because ABC equal to PQR. So equal to AB over PQ the whole square equal to BC over QR the whole square equal to AC over PR the whole square. And this is, reason for this is area ABC equal to area PQR, and this is given to us. Now here I can cancel on either sides. ABC cancels, becomes 1. 1 equal to AB over PQ the whole square equal to BC over QR the whole square equal to AC over PR the whole square. So this is what we had got in our earlier slide. Let us take one ratio at a time. Like first we are going to take this part, okay? So we are going to take as 1 equal to AB over PQ the whole square, which means square root of 1 equal to AB over PQ. So we can say 1 equal to AB over PQ. So PQ equal to AB. This is one part. Now we take the next, and the next is 1 is also equal to this ratio. So we write that out. So we have 1 is also equal to BC over QR the whole square. So take the square on the other side, square root equal to BC over QR. So 1 equal to BC over QR. So QR equal to BC. And now for the third, 1 is also equal to this ratio. So we write that 1 equal to AC over PR the whole square. Take the square on the other side. So under root 1 equal to AC over PR. 1 equal to AC over PR. So we have PR equal to AC. Now if you look very carefully, in these two triangles, the three sides are equal. AB equal to PQ, QR equal to BC, PR equal to AC. So in triangle ABC and PQR, we have shown first here that AB equal to PQ. Then here we have shown BC equal to QR. Then third we have shown this, which is AC equal to PR. So triangle ABC will be now congruent to triangle PQR by SSS test. And that was what was asked to prove, to show that the triangles are congruent. D, E, F are respectively the midpoints of sides AB, BC, CA of triangle ABC. So here we have triangle A, B and C. And now they said that D is the midpoint, here D is the midpoint of AB. So let's mark that. D the midpoint of AB. So that would be somewhere here. Then we have E is the midpoint, so we mark D. E is the midpoint of BC. So BC, and then we will have here, that is our E. And then we have F is the midpoint out here. So these are our midpoints. So in the statement, write given triangle ABC, D is midpoint of AB, then F is again midpoint of AC. We've got to write it in words though. E is the midpoint of BC. Now we have to find the ratio of DEF and ABC. So to find, we need to find area of triangle DEF over area of triangle ABC. This is what we need to find. So we'll just join up DE. Here we'll join up EF and we get the inner triangle DEF. Now if you recall the midpoint theorem, what did the midpoint theorem say? D is a midpoint, F is a midpoint, hence we have DF is half of BC. So that's what we will write. D, F, midpoints of AB and AC respectively. Therefore, I can say DF equal to half BC, which means DF over BC equal to 1 by 2. This is by midpoint theorem. This is equation 1. In the next again, we could say here E is a midpoint, F is a midpoint, hence EF is half of AB. So let's go ahead and write that. So EF are midpoints of AC and BC. Therefore EF equal to half of AB. This is midpoint theorem, or in other words, EF over AB equal to 1 by 2. This is equation 2. And for the last, we know D and F are midpoints. Therefore, DF will be half of AC. So DF are midpoints of AB and BC. So, therefore, we can say DF equal to half of AC by midpoint theorem. So DF over AC equal to 1 by 2. This is equation 3. So if we take up now triangle DEF and triangle ABC, we have already seen that here DF over BC is 1 by 2. So we'll write that DE over AB is 1 by 2. Then we also saw that EF over AB is 1 by 2. So we have EF over AB is 1 by 2. Here I made a mistake. This should not be AB. This should be BC. And the last one, we've seen that DF over AC is 1 by 2. So DF over AC equal to 1 by 2. We have proved this earlier. Therefore, the triangles are similar by SSS test. We show that the three sides are proportional. So we can say the triangles are similar by SSS test. So triangle DEF similar to triangle ABC by SSS test. Now if they're similar, we have that property. We have area of DEF over area of ABC. This is the property we have learned, is equal to DE over BC the whole square equal to EF over AB the whole square and equal to DF over AC the whole square. Now DE over BC we saw is 1 by 2. So this is 1, all of them are 1 by 2. 1 by 2 the whole square, which is equal to 1 by 4. Which means triangle DF over area of ABC is in the ratio 1 over 4. Prove that the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding medians. So here we have two similar triangles. We'll name them as A, B, C, and we have here P, Q, R. So given to us two triangles that are similar. So triangle ABC similar to triangle PQR. And now we require the medians. So let's go ahead and draw their medians. To draw the medians, we have to first take the midpoint of BC here and then join A to the midpoint, and we'll take the midpoint here as D. So these are equal. Then to draw the median, in the next case we take the midpoint of QR, which we will name as S, and now we join PS. So this is the median. So we write down, so AD is median of triangle ABC and PS is median of triangle PQR. Now remember, median is from the opposite vertex to the midpoint. So these are equal. So what we need to prove is the area of two similar triangles is equal to the ratio of the corresponding medians, which means we need to show that area of ABC over area of PQR equal to the square of the medians. We have to show AD over PS the whole square. This is what we need to prove. In the first step, we are going to take the triangle ABD and then we will take the triangle PQS and prove that they are similar. So this is step 1. So we say take, or in triangle, instead of take we can say in triangle ABD and triangle PQS. Now the earlier triangles, the triangle ABC was similar to PQR. So we have AB over PQ equal to BC over QR. And the reason for this is triangle ABC, the large triangle ABC was similar to triangle PQR. So these were the corresponding sides. Now we have AB over PQ. So for BC, I can write twice BD. Because see, this is BC, this whole thing is BC, and this is half of BC because D is the midpoint. So for BC, I can write twice BD. Similarly, for QR, I can write twice QS because it is a half, S is the midpoint. So here I write over twice QS. So this 2 cancels. So I got AB over PQ equal to BD over QS. Now these two angles too are equal. Angle B will be equal to angle Q because they are part of the larger triangle which were similar. So we have also angle B equal to angle Q. And the reason for this is triangle ABC, the large triangle, is similar to triangle PQR. Now remember, we have taken these two triangles for which we already showed AB over PQ. We showed AB over PQ equal to BD over QS. BD over QS. And these two angles were equal. B was equal to Q. B equal to angle Q. Therefore, the triangles are similar. So, triangle ABD, the yellow triangle, similar to PQS by SAS test. Now, if the triangles are similar, we can say now AB over PQ equal to BD over QS equal to AD over PS. We call this as equation 1. So earlier we have already shown AB over PQ equal to BD over QS equal to AD over PS. And why was that? Because we showed the yellow triangles ABD similar to triangle PQR. Now these large triangle ABC and PQR we know are similar. We know triangle ABC is similar to triangle PQR, and this was given to us. Therefore we can say area ABC over area PQR equal to AB over PQ, this is the property, square equal to BC over QR square equal to AC over PR square. But out here we see that AB over PQ equal to AD over PS. So let's put that value in our sum. So we have area of ABC over area PQR, we know is AB over PQ the whole square, but here we have seen AB over PQ equal to AD over PS. So for this now we will put AD over PS the whole square, and we have proved. So we have proved that area ABC over area PQR equal to AD over PS, the two medians, AD over PS the whole square. Prove that the area of an equilateral triangle described on one side of the square is equal to half the equilateral triangle described on one of its diagonals. So here we have a square and we'll name it as A, B, C, D. So let's write given A, B, C, D is a square, all sides equal. That is A, and A. We need to draw two triangles, one on its diagonal. So let's draw the diagonal. So here is its diagonal, and this is a square on its diagonal. This is a not square, a triangle on its diagonal, and we have to draw another one on its side. So here is a square drawn on its side. Let's write that. So we have now AC, say this is P, this is ACP, I put it as P. So a triangle APC drawn on diagonal, and here we have A, we'll name this point as Q, AQB is triangle AQB drawn on side. What we need to show in this sum is that area of the triangle drawn on the side, that is area of ABQ, equal to half the area of APC. This is what we need to draw. So to start with, we know the side is A. Here we have 90 degrees, and we'll use Pythagoras theorem to find AC. So let the side of the square be equal to A. And we know angle D is 90, that is property of the square. So by using Pythagoras theorem, we have A square plus A square equal to AC square. This is by Pythagoras theorem. So we have 2A square equal to AC square. So AC will be under root of 2A square. So A under root 2 will be AC. So our AC is now here A under root 2. So now for the next part, we already had shown that the diagonal was A root 2. Remember, this is an equilateral triangle, so this is A root 2, and this also will be A root 2. So area of PAC will be equilateral triangle, and the formula for equilateral triangle area is root 3 by 4 side square. In this case, the side root 3 by 4, we know the side is A root 2. So that will be A root 2 the whole square. So that will be root 3 by 4 A square into 2. And when you cancel this out, you will get root 3 over 2 A square. So this is area of PAC. Now we'll find the area of the triangle on the side. So this was A, so this was A, and this was A. It was an equilateral triangle, so all sides equal. So area of ABQ will be root 3 by 4 side square. Now the side is A, so it will be root 3 by 4 A square. So this were our two triangles. This yellow triangle is a triangle on the diagonal, and we found the area equal to root 3 by 2A square. And the green triangle is a triangle on the side, and the area root 3 by 4A square. We have to find the ratio. So area on the side, that is ABQ over area, this is P of course, PAC will be root 3 by 4 A square divided by root 3 by 2 A square. So that is root 3 by 4 A square, division, multiplication, chain to multiplication. So here A square. So this cancels out, here becomes 2. So area of ABQ over area of PAC equal to 1 by 2. So area of ABQ equal to half area of PAC. And if you remember, if you look at the figure, this is the area of a triangle on the side, which is equal to half the area of the triangle on the diagonal. In figure 6.43, the line segment XY is parallel to AC of a triangle, and it divides a triangle into two equal areas. Find the ratio of AX over AB. Let's take up the first information. They say this AX divides an entire triangle into two equal areas. This triangle ABC into two equal areas, which means now we need to write is we know ABC is made up of two parts, this part 1 and part 2, and both of them are equal. So I say area BXY plus area AXYC. Now area of ABC will be equal to area of BXY plus BXY, because we know both the areas are equal. We know this area here, this area is equal to this area. So we have now, the reason is BXY equal to area of AXYC. So area of ABC we can say is BXY means 2 times BXY. We'll put this equation 1. We'll have to use this information a little later. In the next part of the sum, we here have 2 similar triangles. Now we know XY here is parallel to YC, which means the corresponding angles are equal. Now which are the corresponding angles? We have this angle here, we'll call it angle 1, will be equal to angle 2. So we'll write down that now triangle BXY, and we are taking the big triangle BAC. We have angle 1 equal to angle 2, and the reason is XY parallel to AC, and these are corresponding angles. In a similar way, we know that this angle here, these 2 angles will be equal. We'll call them angle 3 and 4. So angle 3 equal to angle 4. Same reason, corresponding. So the 2 triangles now are similar. Triangle BXY is similar to triangle BAC by AA test. Now if the triangles are similar, we can use all the properties of similar triangle. That's what we're going to do in the next slide. So in the earlier slide, we showed area of the big triangle ABC was twice the area of that small triangle BXY. Then we write it as 1. And we also showed that the triangles were similar. We showed the big triangle, that is ABC, is similar to 2 triangle. Don't have to write area, we have to write triangle. We showed triangle BAC is similar to triangle BXY. Now if they're similar, we can say area of BAC over area of BXY will be equal to XB, here XB over AB the whole square. That's a property we have learned. So equal to AB over BX the whole square. This is the property we have learned. The ratio of the areas equal to ratio of their sides. In the next step, we do area BAC over area BXY equal to AB over BX the whole square. But for this ABC, what I'm going to do is I'm going to take away this ABC, and instead of that I'm going to write here this value. For ABC I'm going to write twice BXY. So here I'm going to write twice BXY. So what I get now is, and this cancels out, so 2 equal to AB over BX the whole square. I take the 2 on the other side, under root 2 equal to AB over BX. But what I need is a ratio of AX over AB. So let me take this now. I got AB over BX equal to under root 2. Now for AB I write AB, but for BX, look up here, BX is AB minus AX. So for BX I am now going to write AB minus AX, and this is equal to under root 2. And the next, I'll take invertendo. So I invert the fractions. So AB minus AX over AB. Oh, I could just cross multiply. I won't take invertendo. I'll just cross multiply. So I have AB equal to under root 2. I took AB minus AX. I open the bracket. AB equal to root 2 AB minus root 2 AX. This is what I got. So I'm going to take this term on the other side. So it's going to become root 2 AX equal to this. I change the side. So this is root 2 AB minus AB. So root 2 AX, I'll take AB common out. So what remains inside is root 2 minus 1. And I do AX over AB will be root 2 minus 1 over a root 2. I've taken the root 2 on the other side. So I rationalize this root 2 minus 1 over root 2. To rationalize, I do into root 2 into root 2. So that is 2 minus root 2 over 2. This is the ratio of AX over AB. ABC and BDE are two equilateral triangles such that D is the midpoint of BC. So here we have one equilateral triangle which is ABC. It's an equilateral triangle. And we have BDE is also an equilateral triangle where D is a midpoint of BC. So let's mark that. Here is D, the midpoint of BC, and there is another equilateral triangle. So D is a midpoint and we have BDE is another equilateral triangle. Now both of them are equilateral, which means the angles are 60. This angle is 60, 60 and 60. And also this angle is 60, 60, 60. So these triangles are equiangular. All the angles are 60. So we can say the triangles are similar. So we have triangle ABC is similar to triangle BDE. If that's the case, we can use the formula for, or the property of similar triangles. That means area of ABC over area of BTE will be, here we can write will be BC over DE or even BD, because all the sides are equal, whole square. So we have BC, and we know BD here, BD is half of BC because D is the midpoint. So for BD, I am going to write, in fact not for BD, for BC I am going to write twice BD over BD the whole square. Remember, this is BD, this is BD, and here this is half of it. So we have area ABC over area BDE, this cancels, to the whole square, that is 4 over 1. So the ratio is 4 is to 1. So here 4 is to 1. The sides of two similar triangles are in a ratio 4 is to 9. So the areas will be, so area, you can say area 1 over area 2, we know is side over 1 over side to the whole square. This is the formula. So we have area 1 over area 2. Now the ratio of the sides is 4 over 9. So that will be 4 over 9 the whole square, which is 16 over 81. So this is 16 over 81.